Domain and range of circular functions. How about the tangent function? What is tangent of t? Let us look into the domain of tangent of t. So tangent of t is y over x, the y coordinate of our point P divided by x. What happens when our t gets into pi over 2? Look at that. X coordinate is 0. 1 over 0 is undefined. So that means our tangent function has no value when t is pi over 2. So when we are tracing the domain, we will skip pi over 2. It's like we will jump. We will not include pi over 2. And it's the same with 3 pi over 2. When our arc is 3 pi over 2, y over x is 0, again undefined. So we will not include 3 pi over 2 in the domain of your tangent function. So what's going to happen here is whenever we are approaching the vertical axis, we will skip it. So that means we will remove pi over 2, we will remove 3 pi over 2, 5 pi over 2, 7 pi over 2. Those are the odd multiples of pi over 2. We will remove them from the set of real numbers, and the result will be the domain of your tangent function. How about the tangent function? Tangent of t. Let f of t be equal to tangent of t. Tangent of t has no value when t is an odd multiple of pi over 2. We will remove from the set of real numbers those odd multiples of pi over 2. We will remove this, take it away, and the resulting set will be the domain of tangent of t. Now, what is the range of the tangent function? It is the set of real numbers. By the way, this is another notation for the set of real numbers. So the range of tangent of t is the set of real numbers. Why so? Let us pay attention when t approaches pi over 2. When t approaches pi over 2, you know that the endpoint of our arc has coordinates 0 and 1. So if we shall compute for tangent of t, 1 over 0, that's undefined. But let us look into the values taken on by tangent of t when y approaches 1 and x approaches 0. When y approaches 1 and x approaches 0, the resulting value will be a big number. It's like dividing 1, a constant number, by something that is small. And the quotient is going to be a large number. You can try it in your calculator. Let us begin at the bottom. Look at this. 1 divided by 0.01 is 100. 1 divided by 0.001 is 10,000. Okay, so this is the numerator 1. Okay, and our denominator is 0.01, 0.001, so on and so forth. And look at what happens. As x approaches 0 and y is 1 or approaching 1, the value of tangent of t, y over x, approaches infinity. So this trend will continue. It will go on increasing and increasing. On the other hand, when y approaches -1, okay, so we can rotate our arc clockwise, -pi over 2. And here, our endpoint P has coordinates 0 and -1. So again, tangent of -pi over 2 is undefined. But what happens? What happens when y approaches -1, or let's put it at -1, but x approaches 0? And so what happens is this. Let's begin at the bottom. -1 divided by 0.01 is -100. Negative 1 divided by 0.00001 is negative 100,000. And you can see the trend. As x approaches 0 and our y is negative, in the fourth quadrant, y is negative, x is positive. The value of tangent of t goes on to negative infinity. It decreases without bound. And so what happens now is the range of tangent of t is the set of real numbers. It's this. It's from negative infinity to positive infinity. That is equivalent to the set of real numbers. So this is the summary. Pay attention to the range. Another way of writing the range of sine of t is this. This is your interval notation. So in your real number line, this is the origin, 0. This is 1. This is negative 1. And so the values taken on by sine of t would be confined in that interval. The same with cosine of t. Pay attention to the domain of your tangent function. The domain of tangent of t is the set of real numbers except, okay, the meaning of this is like subtraction, set subtraction. You will remove from the set of real numbers the real numbers which is an odd multiple of pi over 2.